एक बार आवाज कंफर्म कर दीजिए, ऑडियो वीडियो सब कुछ क्लियर है. Once you please confirm this sound. So this is the problem with the morning class, students will come lately. एक बार आवाज कंफर्म कर दीजिए. Yes. Neha Rajput, good morning. How are you? Are you following all my classes? Yeah. Is my audio video everything clear, Neha? Is my audio video everything is clear? Yes sir, thank you. Thank you. Good morning India, welcome to GATE Academy. On this global GATE Academy channel we are discussing the measurements. So we have completed, I just joined today sir, good morning. Okay. Yes, thank you. Yeah. On this global GATE Academy channel we are discussing the measurement. This is a lecture number 41 my dear student. So my dear students, try to understand. We are almost completed the electrical measurements. Neha Rajput, almost you came at the end of the course. Okay, so you can follow all my previous classes. You can follow all my previous classes. I have already created a playlist on the electrical measurements, and that was posted in our Telegram channels. So please follow all the previous playlist. Okay, so in the playlist I have posted the electrical measurements. I want to tell you Neha Rajput, where are we? Okay, so my regular students aane wala hai, so I think they will come slowly. So I started in the month of March. I have started this in the month of March 28th. I think I started this course. I think around April first week, March 28th, March 30th, around that week I have started these measurements. Okay, so almost we have started in the March the measurements. Neha, listen carefully what we have covered up to now. I am just explaining. So in the measurements we have discussed the electrical measurements part. So we are having electrical measurements and electronic measurements, and here we have discussed transducers. So dear students, this is for ESE, this is for IES. I think many of the students are writing the IES paper now. Neha, many of the students are preparing for IES. Okay na? So measurements contains electrical measurements, electronic measurements and transducers, but actually for this is for IES, ECE, EE, and anyway IN students don't have IES paper, they have to write ECE EE paper. Next, and these two parts are for GATE. Okay na? So these two parts are for GATE EEE. Neha Rajput, are you from EEE background or ECE background? Neha Rajput, may I know, are you from EEE background or ECE background? Are you from EEE background or ECE background? If you are EEE background, if you are preparing for GATE, so these two topics are essential. If you are ECE background and if you are preparing for IES, then you have to study this transducer also. Okay, so under the electrical measurements, what we are going to discuss, what we have discussed under the electrical measurements, we have discussed the error analysis. And under the measuring instruments we have discussed. So measuring instruments we have discussed. Those who are following my classes in the beginning onwards, so they can understand measuring instruments. Under the measuring instruments we have completed PMMC, we have completed moving iron, we have completed. Okay, next dynamometer we have completed. Next, wattmeter we have completed. Next, energy meter we have completed. energy meter we have completed. Next, electrostatic voltmeter we have completed. So these are the major instruments, all the measuring instruments. Triple E, then you have to follow the entire syllabus. Okay. So if you are following for the GATE, so these are the measuring instruments. Okay, na? And after the completion of this, we have also discussed the bridges. Bridges we have discussed. In the bridges, we have discussed the DC bridge and AC bridge. DC bridge and AC bridge. Under the DC bridge, we have discussed the Wheatstone bridge. Wheatstone bridge, Kelvin double bridge, Kelvin double bridge. Under the AC bridges, we have discussed all the RLC bridges. So you can cover all the topics I have covered. I have started from Maxwell. I have started the Maxwell inductance bridge. I have discussed the Maxwell inductance capacitance bridge. Maxwell inductance capacitance bridge I have discussed. Okay, na? Next, Anderson bridge. Anderson bridge we have discussed. Next, Owens bridge we have discussed. Hayes bridge we have discussed. D.Sathish bridge we have discussed. Sharing we have discussed. Wien's bridge also we have discussed. So all these topics are over. I have elaborately discussed all these topics in almost 40 lectures. I have given you the guidelines of this. And after this, we have also discussed the resistance measurement, low resistance, medium resistance, high resistance. All these also we have discussed. Okay, na? Just I am giving the guidelines. Neha Rajput, kaha tak ho gaya syllabus. Okay, we are almost at the end. So these all topics we have discussed in the all playlist. We are having this. Next comes electronic measurements. Under the electronic measurements, we are now discussing the Q meter. Yesterday we have discussed the Q meter. Next, we are having pending of two topics. One is the digital voltmeter, other one is the cathode ray oscilloscope. So these two are going to be pending. Next, under the transducers, measurement of non-electrical quantities. Measurement of non-electrical quantities. So this one, temperature, pressure, flow, displacement, velocity, force, light. Okay, na? So like this, we are also having two sessions I have taken for non-electrical quantities. Okay, Neha Rajput. Now we are pending with only two topics. One is the DVM and the other was CRO. And yesterday we have completed Q meter. So this is what we have completed till today. Is it clear, Neha? If you understood, just confirm me by showing some thumbs, by showing some symbols. So maybe couple of 2 days, maximum 2 days, I am going to close the syllabus of measurements. Chalo, in the last class, I was talking about the Q meter. In the last class, I was talking about the Q meter. So how to understand this Q meter? Listen carefully. So if you see this particular Q meter in the last class, we have discussed this Q meter problems. Yeah. So this is our Q meter. Okay. So this is our Q meter. So if you see this particular Q meter circuit, what is the purpose of Q meter? The Q meter is used to find out the Q of a coil. The Q of a coil, which is nothing but omega L by R or 1 by omega CR. Have you followed the previous session? In the previous session, I have given this. In the previous session, I have given this Q of a coil. Next, it is also find out the self-inductance of a coil. It is also find out the resonant frequency of the coil, and it is also find out the distributed capacitance of the coil. So these are the things yesterday I have discussed. Whatever the coil is there for which you want to measure the Q factor, that coil is tested by placing between the terminals T1 and 2, and we are keeping a shunt resistor so that some voltage can be collected here. The voltage is collected across the shunt, that is the voltage we are supplying. Next, by keeping another variable capacitor, what we are doing, we are tuning this particular capacitor. We are tuning this particular capacitor such a way at resonant, the voltage across the capacitor is going to be the maximum voltage. The voltage across the capacitor is going to be the maximum voltage, so that the Q can be taken as EC by E. Okay, now the voltage across the capacitor will be Q times of E. Why? Because we know very well that the relation between the relation for the Q factor, you know very well. The Q can be defined as voltage across the inductor, which is the reactive component, by resistive component, or voltage across the capacitor by voltage across the resistor. Yes or not? So this one reactive component and this is a resistive component, this is also capacitive reactive component and this is also resistive component. So now by using this, we are tuning this particular capacitor such a way the voltage across the capacitor is equal to maxima. So then we can write the expression. Why? Because this is nothing but the supplied voltage. At resonant the circuit becomes pure resistive circuit. Yes or not? That is what I want to tell you. So if you see this particular diagrams, what is happening here? See here. So this is the resonant condition of the phasor diagram. So if you see the relation between the resistance and if you see the relation between the resistance and voltage across the resistance and current and voltage across a capacitor. So we know very clearly the current and resistance both are in phase. Am I right or not, Taranjim? So this is current passing and the voltage across the resistor, that is I into R naught. So this is I into R, that is in phase. So the current passing through the resistor and the voltage across the resistor both are in phase. So that is our E, supply voltage. Now the phase angle, if you see for the inductance component, so this is the inductive component. So this is our the voltage across the inductor, that will be reactive component, that will be 90 degrees. Now the resultant of these two, why? Because if you take a RLC coil circuit, this is our coil, the coil will be having some inductance and the coil will be having some resistance. So this is the resistance of the coil, this is the inductance of the coil, and we are also taking a variable capacitor here. So if you take this variable capacitor, this is a variable capacitor. Okay, so now the voltage across this, and voltage across this, if you see here, so this is the I into XL actually, and this is the I into R. Okay, na? And this is also I into XC. Am I right or not? I into XC. So the total impedance is going to be at resonant, the total impedance is going to be R plus XL minus XC. But at resonant frequency, XL is equal to XC. Am I right or not? At resonant frequency, XL is equal to XC. So then it becomes like a pure resistive circuit. It becomes like a pure resistive circuit. So if you see the resultant of these two, the resultant of these two is nothing but our EL. So this is a voltage across the inductor. Why? Because the inductor, the coil is having the resistance component and inductance component. So this is our test coil. The coil is having some resistance and inductance. So the voltage, yes, Tanjim Khanum, good morning. The voltage across this inductor is equal to its resistance component, its inductance component. Similarly, if you see the voltage across this particular capacitor, that is going to be lag by 90 degrees. Is it clear? That is going to be lag by 90 degrees. You know very well this code, civil. You know very well this code. For a capacitor, current leads the voltage. For an inductor, voltage leads the current. So this is capacitor. For a capacitor, current leads the voltage. Okay, na? And for inductor, voltage leads the current. Do you understand? Is it clear? So for a capacitor, so civil code you try to understand. For capacitor, current leads V by 90 degrees, and for inductor, V leads I by 90 degrees. So for a capacitor, the voltage is going to be lagged. So if you draw, so what is the voltage across a capacitor? If you take the resultant of this particular, so this is a parallelogram. If you draw, so this and this are both are going to be same. So EL is equal to EC. Is it clear? So now there is going to, the circuit is going to become like a pure resistor. XL is becoming the XC. Is it clear? Chalo. So that's what we have done yesterday. So if you see this expression now, Neha, are you following? Neha, the new student, are you following? Neha Rajput. So the voltage across a capacitor is I into XC and I into XL. So that's what I was talking. EC is equal to I into XC, but at resonant XC is equal to XL. Am I right? At resonant XC is equal to SL. So we know the pure resistive circuit, that is I into R. So it is a pure resistive circuit, that is I into R. So now if you take any one of these two ratios, if you take this EC ratio and E ratio, what happens? The EC by E is equal to becoming as I into XC by I into R, or I into XL by I into R. Am I right or not? So this I gets cancelled, this I gets cancelled. So this is nothing but Q. So EC by E is equal to Q. Please try to remember this format. So from this, now we are going to do some beautiful problems. Okay, chalo beta, I am going for the problems. So try to answer this question. So this is my first question. Try to answer this. Okay, I will go for first a simple question. I will go. Yeah, what is the answer for this question? Yeah, what is the answer for this question? Try to do this question. Question is visible, right? So try to do this. Q meter is a very rarely asked topic. So try to do this. How to do it? A lossy coil having series, a lossy coil having series resistance 0.8 ohms is resonated at resonant frequency FR is equal to 10 kilohertz. Resonant frequency FR is 10 kilohertz, and with a capacitance of 2 microfarads, calculate the Q value. What is the Q of the coil? Jaldi bataiye. What is the Q value of the coil? Tanjin Konam, what is the answer? A lossy coil having series resistance of 0.8 ohms resonated at resonant frequency FR 10 kilohertz and with a capacitance 2 microfarads. So if you see this particular circuit, so this is our lossy coil which is having a resistance, and it is resonated by tuning a capacitor. It is resonated by tuning a capacitor such a way the voltage across the capacitor EC is equal to Q times of this applied voltage E. So this is our coil R and LC. So this is our test coil. So now what is the question asked? He is asking the Q of the coil. So what is the answer? So we can use the formula Q is equal to omega L by R, but L value is not given. So 1 by omega CR. Very simple. Sir, can you please tell me when your measurement subject will be provided to G drive student? Shaili Patel, G drive student के लिए May month में आएगा. Why? Because right now the recording is going on. Right now the recording is going on. Okay na? Shaili Patel, you are going to get the G drive course maximum in 10 days. Okay na? Maximum in 10 days. So this is April 13. By May 10th, the recording content will be available. Okay, the recording is going on because I have some issues. This COVID conditions have disturbed me a lot. One of my family member is taking treatment in the hospital. So that's why my recording बहुत so चल रहा है. So once the recording is over, I will update to the management. Okay, so the G course will be available by May 10th. Okay, Shaili Patel, is your question is answered? By May 10th it will be available. Almost I have recorded around 60 hours up to now, but still some 60 hours more. Why? Because in G drive I am going to discuss all gate problems. All previous year gate, last 15 years gate problems I am going to discuss in the G drive course. Okay beta, thoda sa patience. Why? Because I am regularly counseling one of my family friend who is suffering with COVID in a hospital. So because of that I am not able to produce by April 30. Actually he was able to produce by April 30. थोड़ा सा delay हो रहा है. Sure, I will update you by May 10th. You are going to get it. Okay, चलो. So what is the answer? Very simple question. 1 by omega CR. So frequency is given, right? Yes, the frequency is given. So this is 2 pi f CR. So what is the answer? So 2 into 3.14 into the frequency is given as 10 kilohertz. 10 into 10 power 3, and the C is given as 2 microfarads, 2 into 10 power minus 6, and the resistance is given as 0.8 ohms. So if you simplify, how much you are going to get? If you simplify, the answer is going to be B. The Q factor of the coil is 10. Chalo, Tanjim Khanam, answer is B. Neha, you got the answer? Very simple questions. On Q meter, you are going to get very simple questions. Don't miss this. These are previous year questions. Chalo, one more question. One more question. Try to answer this. Try to answer this. Jaldi. Try to answer this beta. A coil with resistance R 0.085 ohms is resonated at a frequency F is equal to 10 kilohertz and with a capacitance of C 0.5 microfarads. Then calculate the inductance of the coil. Simple questions, don't miss them. Calculate the inductance of the coil. Again the same formula. So we can use Q is equal to omega L by R. So omega L by R. So this is 2 pi. So 2 into 3.14 into F. Frequency is 10 into 10 power 3 and inductance is not given. Okay, inductance is not given beta. So I think this how to do this? How to do this? Q is equal to omega L by R or 1 by omega C R. So by using this information, first you can find out the Q na. So first you can find out the Q value. Am I right or not? Chestunara? Change. I need the answer. Shaili Patel, are you following my YouTube classes? Shaili Patel, are you following my all YouTube classes? Shaili Patel, are you following my all YouTube classes? Shaili Patel, are you following my all YouTube classes? Yeah, answer please. I am expecting the answer beta. Simple question. How to do it? What is the answer, Ananja Bose? Neha Rajput, yes, 10 was the correct for the previous. But what is the answer for this? Q is 100. Ananja Bose is telling 100. Okay. So Q is equal to 1 by omega CR. So this is 2 into 3.14 into what is the frequency? The frequency is given as 10 kilohertz. 10 into 10 power 3. C is what? Is given 0.5 microfarads into resistance is given as what? 0.085 ohms. So what is the answer for the Q? Q is coming as how much beta? Q is coming as 100. Okay, I will take the answer of Mr. Ananja Bose. I am taking your answer 100. So if I take this 100 here, omega we know very well, that is 2 into 3.14 into frequency. The frequency is equal to 10 kilohertz, 10 into 10 power 3, and you can find out the inductance. R is given as 0.085 ohms. So how much you are getting L? What is the answer? 0.5 millihenry, 5 millihenry, 0.9 millihenry. Yes. 0.5 millihenry. Yes. 0.5 millihenry. So you can do like this. Or you can follow the resonant frequency concept. The resonant frequency concept also we can follow. That is a method 2. That also you can do, right? In 2 ways you can do. The resonant frequency is equal to 1 by 2 pi root LC. So C is given, resonant frequency is given. You can find out the L also. In both the cases you can do. So the right answer is 0.5 millihenry. No sir, not 100. That was a mistake. Okay. Okay, how much that is? Q is how much then? What is a Q then? How much you are getting? Yes, 0.5 millihenry is the right answer. Q is coming around 374. Q is not 3. Q is coming around 374. I think Q is coming around 374. Okay. So the right answer is 0.5 millihenry. Yes, 0.5 millihenry. Chalo, next question. Yeah, answer this question. Try to answer this question. A practical Q meter is shown in the picture. Calculate the percentage error in measurement of Q due to shunt resistance. So there is a shunt resistance here, beta. So this shunt resistance value is 0.5 ohms. So the shunt resistance value is 0.5 ohms. A practical Q meter is shown. Calculate the percentage error is the measurement of Q due to RSH. The RSH is given as 0.5 ohms and the test coil inductance is given as 20 millihenry and the resistance is given as 5 ohms and the variable capacitor that we are using is 2 microfarads. The variable capacitor is giving us 2 microfarads. So what is the right answer? Due to the shunt resistance, how to find out? How to find out? In the last class I told you, the Q true value is equal to omega L by R. If you consider the shunt resistance, then it will become omega L by R plus RSH. Similarly, Q true value, if you take 1 by omega CR, yes or not? But if you consider the measurement value including this distributed capacitance, that C plus CD into R. As long as CD is not given, you can take it as 0. But in this question, the question asked is due to shunt resistance. So what is the way percentage error? So percentage error we have to find out. So percentage error is equal to, so Q measurement minus Q true by Q true into 100. So please do it. What is the answer? You are going to get it. So question asked is percentage error, practical percentage error in measurement of Q. So how to do this? So Q measurement, if you see here, so this one you can take like this. So I can take this as omega L by R plus RSH minus omega L by R by omega L by R into 100. So if you take omega L common, it will become 1 by R plus RSH minus 1 by R by 1 by R into 100. Okay na? So please do this calculation part. So what you are going to get? R minus R plus RSH divided by R whole divided by 1 by R into 100. Yes or not? Simplification kar do. What you are going to get? So this will become R minus R minus RSH by R into R by 1. R gets cancelled. So how much you are going to get? Yes. How much you are going to get? Please make a calculation part. Make the calculation part. How much you are going to get? What you are going to get here? Any mistake we have done in the Q value? So directly value you can find out, right? Directly you can find out the value. So what is the answer? Answer please. How much you are getting? Question display karo. Okay. Question display ho raha hai na? Please do it. Yeah, please do it. कितना आ रहा है? R plus RSH. Yes, in the denominator R plus RSH. There will be R plus RSH also. Yes. Make it fast here, no problem. Directly you can do here now. So what is the Q true value here? Directly I can do like this. RSH is given. So what is the Q true value? Q true value is omega L by R. So that is R shunt is there here. So this R is 5. So this is omega L by 5. Next, Q measurement क्या होगा? Omega L by R plus RSH होगा. That means omega L by R is 5, RSH is this 5.5 ohms. So please find out the percentage error. Percentage error कितना आएगा? Measurement value minus true value by true value into 100 ना. So that is omega L by 5.5 minus omega L by 5 divided by omega L by 5 into 100. So what is the answer you are going to get? Definitely you are going to get minus, okay na? So what is the answer? Minus 9.09%. So the right answer is minus 0.9%. Is it clear? Neha Dupia, is it clear? Neha Rajput, is it clear? Chalo. Right answer is minus 9 point. Minus is there. Please take care of this. Minus term is coming here. So if you take this out, you are going to get omega L common, right? So you can simplify it. So 1 divided by 5.5. Don't make mistakes here. Am I right or not? Yes. Into 100. Don't make mistake. Minus 9.09% is going to come. Chalo. Minus. So there is a plus term here, minus term here. So be careful. Next question. Yeah, answer this question. Very simple questions will come, but don't miss the concepts. Chalo. Try to do this question. The given network is under series resonance. Find the quality factor of the coil. Given supply voltage is 230 volts AC. So this supply voltage is given as 230 volts AC. Okay. So this is the resistance and inductance of a coil, and this is a variable capacitor. The voltage across the capacitor is given as 400 volts, and the current passing in the circuit, is given as 2.3 amperes. Question asked is Q value. Excuse me. Question asked is Q value. So options given 173.9, 100, 1.74 cannot be determined. Try to do it. 173.9, 100, 1.74 cannot be determined. The given network is under series resonance. Find the quality factor of coil. Given supply voltage is 230 volts AC, VC is 400 volts, IA is equal to 2.3 amperes. Option A is given as 173.9, option B is given as 100, option C is 1.74, cannot be determined. 1.74 maybe. Why maybe, Ananja Bose? Why are you not accurate? You can do it now. So what I told you. So this is the voltage we are giving V. We are tuning this capacitor so that the voltage across the capacitor is going to be maximum. So under this condition, so what I can take, the VC by V ratio is equal to Q na. Don't forget here, the voltage across the capacitor is always I into XC. The voltage in the resistive circuit, that is I into R. So if you simplify this, we are going to get 1 by omega CR. That's it. That is a Q factor. So directly you can use that formula. So VC is given as 400 volts and V is given as 230 volts. That's it. That is the answer. No need to confuse beta. Very simple. The question looks lengthy, but the answer is very clear. The answer is 1.739. So the right answer goes to option C beta. Option C is the right answer. Is it clear? Neha, is it clear? All of you followed? So 1.74 is the right answer. Okay, chalo. That only I used, sir. Okay. Then why maybe? Chalo, next question. Next question, try to answer this. Is the question is visible, Neha? Tanjim, is the question is visible clearly? Yeah, please do it. What is the answer? A high Q coil having a self capacitance. Self capacitance means what? That is a coil. Generally, I told you, if this is the coil, this coil is having resistance, and I told you this coil is also having some distributed capacitance. Do you remember? So this coil is having distributed capacitance. So that's what we have discussed in our previous diagrams. That's what we have discussed in our previous diagrams. So see here, this coil will be having distributed capacitance. Every coil will be having some distributed capacitance. So this is the diagram. Don't confuse with the CD and C. C is variable capacitance. Variable capacitance here. This is a variable capacitance. CD is the self capacitance, which is also called self capacitance of a coil, or which is also called as distributed capacitance of a coil. So who is variable in these two? Anindya Bose, Tanjim Khanam, in these two who is variable? C or CD? C is variable, CD is fixed. CD is fixed. When you choose a coil, its CD value is fixed. Okay, now chalo, let us go for the question. So what is the question? A high Q coil having a self capacitance is tested with Q meter. First resonance was obtained at omega 1 5 into 10 power 6 radian per second with capacitance 1000 picofarads, and second resonance was obtained at omega 2 10 into 10 power 6 radian per second with capacitance 210 picofarads. Then the value of distributed capacitance is dash. Yesterday I have clearly explained, Tanjim Khanam, Anindya Bose, yesterday I have clearly explained, to find out this distributed capacitance, what I am doing, first I am choosing a particular resonant frequency FR1, then I am starting the varying this particular capacitance C1, so that this voltage from the low goes to the maxima. Once again I am explaining Anindya Bose, Tanjim Khanam, Neha. Why? Because this method is most confusing method. I want to find out this particular distributed capacitance of a coil. I told you yesterday, in a coil when a current flows alternatingly, because of the entering flux and the leaving flux, at the top and bottom of the coil there is a polarity is going to be happened. Because of this polarity there is a capacitance for the coil also. There is a capacitance for the coil also. Okay, in electrical circuits we'll use a word as stray capacitance. Do you remember stray capacitance word in electrical subject, Tanjim Khanam and Neha? So just like that, here also when a coil, when a current goes and when a flux enters and exits, because of that opposite polarities, we are going to have some distributed capacitance. So whenever you take a coil, that coil is having some inductance, that coil is having some resistance, that coil is having some self capacitance or distributed capacitance. Okay na? And that coil is having Q factor. What are the parameters of a coil? Once again I am explaining. The coil is having resistance, the coil is having inductance, the coil is having self capacitance, the coil is having Q factor. So these all are the parameters of the coil. Okay, so to find out this particular capacitance, first what I am doing, I am taking a particular resonant frequency, then I am tuning this capacitor to minimum to maximum or maximum to minimum, such a way the voltage across this voltmeter is going to become maximum. Everything is fixed now. Now I am choosing another frequency FR2, suppose, which is having some mathematical relation, which can be 2 times, which can be 3 times, something FR2. Then what happens? Definitely the resonant gets disturbed. definitely the resonant gets disturbed. My dear student, resonant can occur only for a particular frequency and for a particular variable capacitor. Then resonant get disturbed, then what happens? This particular Emax will come here. Emax will come here. Now what I will do? I will change this C1 to some other value C2. Just like FR1 change it to FR2, the C1 change it to C2, and again what happens? This will go to the maxima. In these two cases, we have to consider the distributed capacitance also. Then how to do this problem? So first resonant frequency is given as omega 1. So what I can do now? Omega 1 f is equal to 1 by 2 pi. Am I right or not, my dear student? Are you following, my dear students? Any doubts here? Tanjim, Neha Rajput, are you following? Please give the response there in the middle of the class. Please give the response. Otherwise, we cannot understand what you are thinking in your mindset. Is it clear? Tanjim, clear? So what is F? F is equal to 1 by 2 pi root LC, but LC, what we have to consider? We have to consider CD plus C1. This is F1. Next, what is F2? F2 is equal to 1 by 2 pi square root of L CD plus C2. So if you send this 2 pi f here, so omega 1 is equal to 1 by root L CD plus C1. Omega 2 is equal to 1 by root L CD plus C2. Now let us take the information given. Omega 1 is 5, omega 2 is equal to 10. That means if you take omega 2 is equal to 2 times of omega 1 na. Omega 2 is equal to 10 radians and this is 5 into 10 power 6 radians. Omega 2 is equal to 2 omega 1. So directly I can use that relation. So 1 by root over L into CD plus C2 is equal to 2 times of 1 by root over L into CD plus C1. In both the cases, the distributed capacitance only fixed, C1, C2 are variable. So if you take the square of it, you are going to get 1 by L CD plus C2 here, and this will be 4 beta, and this is 1 by L CD plus C1 beta. So now what happens? L gets cancelled. So what is the CD that we have to find? So I think yesterday I have derived the expression also. So 4 into CD plus C2 is equal to CD plus C1. So if you write this, 4 CD plus 4 C2 is equal to CD plus C1. So CD, if you bring this side, 4 CD minus CD is equal to any mistake we have done? CD plus C1, and this is 4 CD plus 4 C2. Yeah, C1 minus 4 C2. So this will become 3 CD is equal to C1 minus 4 C2. So CD we can find out C1 minus 4 C2 by 3. So what is the C1? He has given in the question 1000 picofarads. First one is 1000 picofarads, and this is minus 4 into second one is 210 picofarads. 210 picofarads divided by 3. What is the answer beta? Jaldi bataiye. कितना आ रहा है? So 1000 minus 4 into 210. So we are getting, sorry. कितना आ रहा है आंसर? 160 divided by 3. I am getting it as 53.33 picofarads. Do you understand, dear students? So the right answer is 53.33. Clear? Neha, Tanjim, Aninja Bose, is it clear beta? Chalo. So these are some good questions, quality questions, easy questions. Especially these type of questions are more important. In IES paper. Electronic measurements is a very underrated subject. Okay na? Very fixed syllabus. Tanjim, very fixed syllabus. Q meter, DVM, CRO. Q meter, DVM, CRO. Chalo. Next question. Yeah. So let me take some more questions are there. Yeah. So try to answer this question, very simple, of course. This is also asked. Okay. Quality factor defined as dash. Quality, sir, that CD formula is not valid for F2 is equal to 3F1. Yes, it is not valid. Tanjim Khanam, that is not, I am not taking it as a formula, I am deriving it. I am not taking it as a formula, Tanjim, I am just deriving it. This is not the formula, this is not the formula beta, this is not the formula. This is not the formula for all. This is not formula for all. Just I have taken this and I have proved it. It is not the formula. Tanjim Khanam, don't think it as a formula. It is only, this is, if F2 is equal to 2F1, then this. If F2 is equal to 3F1, again you have to do. If F2 is equal to 3F1, again you have to do it. Okay, na? Don't think it as a formula. It is not applicable formula for all. It is F2 is equal to 2F1, and if you take F2 is equal to 3F1, again the situation changes. That's why you please follow this methodology. That's why I follow this methodology. W2 is equal to omega 1. In the question he has given na. He given in the question. Given in question, Tanjim. It is given in the question. Okay. Chalo. It's a very simple question, but sometimes the basic questions are also important. What is the Q factor? Quality factor is defined as dash. Ratio of energy dissipated per cycle oscillation in a circuit to a maximum energy stored in a circuit. Ratio of maximum energy stored in a circuit to energy dissipated in a circuit per cycle. Ratio of reactance to resistance. Ratio of resistance to reactance of the element. So what is the right answer? My dear students, Q factor can be defined in many ways. Q factor can be defined as energy stored in a inductor, energy stored in a coil, energy stored in a coil by energy dissipated over a period of time, Okay na? Chalo. RQ is also defined as voltage across the reactive element divided by voltage across the resistive element. Or Q is also defined as that's what VC by VR. So what is the right answer here? The right answer is ratio of maximum energy stored in a circuit to energy dissipated in a circuit per cycle of oscillation. Is it clear, beta? Is it clear? Chalo. That's enough for today. Okay. So in tomorrow's class, okay, so beta, tomorrow's class will start the Next topics pending. In tomorrow's class I am starting the DVM. Okay, dear students, in option C, Tanjim Karam, you are saying option C. How it is going to be option C? It is ratio of reactance to the resistance. Is it reactance to the resistance? Is it just XL to ratio of reactance to the resistance of element, ratio of resistance to the reactance of the element? No. It is not the ratio of the reactance. It is a voltage across the, remember my dear student, if you take a, this is not absolutely correct, just we cannot take the resistance. Why? Because at resonance, yes, sir, option B is wrong. It's not maximum energy. Ratio of maximum energy stored in a circuit to energy dissipated in a circuit per cycle of oscillation. Why it is wrong? Why it is wrong? Ratio of maximum energy stored in a circuit. Why? Because it is half I square L. Half I square L na. Half I square L. The maximum storage capability, the energy storage capability, okay na? In that energy storage capability, how much you are going to get, how much you are going to lose. Very good. Omega L by R and XL is equal to omega L. Yes. So option B is wrong. Ratio of maximum energy stored in a circuit to energy dissipated in a circuit per cycle of oscillation. Yes, you are correct. The maximum cannot be taken here. Yes, the maximum cannot be taken. So the right answer goes to option C. The right answer goes to option C. Why? Because at a particular period of time, how much energy is stored? Option B is correct or option C is correct? What is the confusion here? What is the confusion here, beta? See, if you see now, what is asking here? Ratio of maximum energy stored in a circuit to energy dissipated in a circuit per cycle. It is very clearly given now, per cycle. Tanjim, it is given per cycle. See, if you take only the resistance of reactance, it is not a standard definition. Why? Because at resonant, what is happening? At resonant, we are taking the voltage across the inductor and voltage across the resistance. Dear students, try to understand this point. If you take a test coil, that is purely depends upon the, dear student Tanjim, it purely depends upon the frequency. Q depends on frequency. Yes, I am also confused. Q depends on frequency. Then definitely this particular supply voltage frequency matters. Okay na? So at what frequency it is coming, that's why we have to take the voltage across the inductor and the voltage across the resistor. This voltage across the inductor is VL, the voltage across the resistor is VR. The voltage across the inductor is VL, the voltage across the resistor is VR. So if you take the Q component, the voltage across the inductor VL we have to take and voltage across the resistor we have to take. That includes the frequency. Why? Because the voltage across the inductor, that must be in series na. So I into XL and I into R. Okay. Yes. Option C is correct, sir, because in definition there is no matter of maximum energy. Option B is the actual definition of Q factor comes from resonance. Himanshu Bharati, energy stored is half Li square. So energy is same whether we call it stored energy or maximum energy. That's it. Tanjim, first of all, you come out of this. It is not just a ratio of, we cannot define as reactance to resistance. It is not the definition as reactance to resistance. Try to understand. It is actually the voltage across the capacitor or voltage across the inductor to the voltage across the resistor ratio. Why? Because at resonance, what is happening? At resonance condition, the XL is becoming XC. At resonance condition, the XL is becoming XC, then the circuit is becoming pure resistive circuit. Yes or not? then the circuit is becoming pure resistive circuit. When the circuit becomes pure resistive circuit, then only we are going to get the maximum E here. E is equal to IR. You are taking the ratio of pure resistive circuit here and we are taking this as EL. Is it clear? Is it clear, my dear student? This I into XL, have you observed this EL is equal to EC by E? Have you observed this? Have you observed this? XL is equal to XC. Have you observed this? See why you have taken this relation? Why you have taken this relation beta? XL is equal to XC we are taking now. IL, XL is equal to XC we are taking. I into XL, XL is equal to XC we are taking at resonant. At resonant these two are equal na. At resonant these two are equal. Yes or not clear? Even VL by VR can be derived from option B statement. Yes. VL by VR can be derived from option B statement. That's what. You cannot take only the resistance, only the reactance component and resistance component. Fundamentally what is happening, at a resonant condition only the circuit is becoming like pure resistive circuit. When it is taking pure resistive circuit, then comes here IR. Then comes here IR. That is the most important point. Then the circuit becomes pure resistive circuit. So that's what I have discussed in our previous diagrams. See here. See here. Yeah. So this is the point you have to understand. When at the resonance, what is happening? This particular component is going to become the standard component. At resonance, it is going to become the resultant of these two na. So this is the EL. Try to understand. So this is the EL. And this is our EC. Do you understand? So at resonant what is happening? At resonant what is happening? This is the resultant E. So this is our resultant E. At resonant condition this E is happening or not? E is equal to R into I naught is happening. So that's why. Yes. Is it clear now, Tanjim? It becomes like a pure resistive circuit. Then only the voltage across a capacitor is going to be maximum. Okay. So that is what I was talking. That's why to understand this resonance condition is most important. Is it clear, Tanjim Khanam now? At resonant condition, the circuit, you have to understand this with the resonance condition, then only the right answer. Okay. So that is a perfect methodology to answer this question. Chalo beta. So the right answer goes for this question as what? Option B is the right answer. So don't think as per our definition is it voltage. Not just a resistive component of reactive component of resistive component. That is not the standard. That is not the standard. Just if you are saying reactive component by resistance. No, it is not reactance. It is voltage across the reactance and voltage across resistance. Is it clear now? Himanshu Bharati, is it clear? It is a voltage across the reactive and voltage across the resistive. That is the beauty of this resonance circuit. Chalo beta, enough for today. Tomorrow we'll start discussing of the CRO. Okay. So tomorrow's topic will be CRO, cathode ray oscilloscope. So in cathode ray oscilloscope, I am not discussing much about the theory. I am going to discuss only how to measure the frequency and how to measure the phase. So this topic only important, especially for the Lissajous patterns. That topic we will discuss tomorrow. Okay. In tomorrow's class, we will discuss this Lissajous patterns. Himanshu Bharati, are you enjoying the classes? Are you enjoying the classes? Half I square L is the maximum energy stored. That's what I am telling. So per unit cycle, what is the maximum energy storage capability of an inductor? That is half Li square divided by energy dissipated. Energy dissipated is nothing but what? Energy is nothing but power into time na. Yes, that is I square RT. That's it. Chalo beta. Tomorrow's class, please come. Tomorrow's class and the next class, that is going to be the last class. After the CRO, I will start the DVM, digital voltmeter. Chalo beta, love you all, take care of your health, we'll meet tomorrow. Jai Hind.